Hello and welcome back. This is the second part of Section 6 in the prerequisites chapter on rational expressions. So in the last video we looked at multiplying rational expressions. So this video will look at adding and subtracting. And in the first instance we'll just look at fractions that have the same denominator. This makes things a lot easier. Essentially, all we do is as we look at the numerators, we'll add or subtract them as necessary, and then once we have the fraction, then we want to simplify. And simplifying just corresponds to factoring the numerator and denominator, and then canceling. So this should be fairly straightforward. Let's look at this example here. So we've got x over x plus 1 minus 3x plus 2 over x plus 1. They have the same denominator, so we don't need to change anything, and we can simply subtract these two expressions. So we'll be able to put everything over one fraction, over one denominator, excuse me, and I'll take x, and I want to subtract the top of this fraction. And it's important that this is in parentheses, because I'm going to subtract all of 3x plus 2. I need to subtract both the 3x and the plus 2 onto here. I'm not just subtracting I'm not just subtracting the 3x, I'm subtracting the entire top of that fraction. So then the next thing to do will be to distribute this negative sign. If I'm subtracting 3x plus 2, that'll be the same thing. I can distribute the negative sign, so it'll be minus 3x minus 2. This is all over x plus 1. And when I simplify this, x minus 3x is minus 2x. And then I can subtract 2. And I can put this all over x plus 1. And here, what I notice is that, this is now not simplified anymore, because I've got minus 2 as a factor of both of these terms. So if I factor that out, I have a minus 2 times an x, minus 2 times 1, and oh look, everything cancels. The x plus 1 will cancel with the x plus 1 on the bottom, and what I'm left with is exactly negative 2. Now, because I canceled this factor of x plus 1, I know that x can never be equal to negative 1. So this is just something important to keep in the back of your mind as you're doing these. We don't want to plug in an x that would give us something that we can't compute. I can't plug a negative 1 into this first fraction, otherwise I'd be dividing by 0. So I'll just keep track of that, and at the end I'll say, this expression is equal to negative 2, except when x is equal to negative 1, and I can't even plug that in. So when fractions have different denominators, we'll have to find the least common denominator. And I'll preface this by saying it's not important. This least part is important to find a common denominator. It doesn't have to be the smallest one. It's a lot easier if it's the smallest one. And I can give an example of this in a second. So what we'll do to find the least common denominator, the LCD, is we will factor both denominators, and then we'll list the factors of the first denominator. Say in this example down here, we'll list the factors of x plus 1, and then we will add in the factors from the second list to form this product. So let's look at this. First, we'll look at this first denominator, x plus 1, and we will factor it. It's already factored, so we don't have to do anything. And then we'll look at the second factor, which will be an x minus 1, and we'll factor that. It's already factored. So now let's form our list. We'll list the factors from the first one, and any factors from the second one that aren't in this list already, we'll add them in. So we have an x minus 1. This isn't in our list. So we'll add that in, and then the least common denominator will be this product, x plus 1 times x minus 1. So that was pretty easy here because both of these denominators only had one factor. Let's look at something that has multiple factors. So now we'll need to do the same thing. Let's look at the first factor. In our first fraction, we've got an x squared minus 9, and we'll need to factor this guy. This is an x squared, this is 3 squared, so we have a difference of squares. This means that I can factor this into x plus 3 and x minus 3. Next, we've got x squared minus 6x plus 9. And again, what we'll do is we'll notice that I've got an x squared and a 3 squared, and this middle term is going to be 2 times x times 3. So I can factor this into x minus 3 times x minus 3. This is just x minus 3 squared. Okay, so we first form a list, and we'll start listing all of the factors of the first denominator. X plus 3 and x minus 3. Next, we have to add in all of the factors that are missing that would be in the second denominator. So the second denominator has 2 factors of x minus 3. Our list has 1. We need a second one. And there we go. So now our list right here has every single factor from the first denominator and from the second one. So our least common denominator is now just the product of everything in this list. It'll be x plus 3 times x minus 3 times x minus 3. So now that we know how to find the least common denominator, we can add and subtract fractions now that have different denominators. The first thing, clearly, will be to find the least common denominator, and then to rewrite both fractions, both expressions with that least common denominator that we found. This is just like adding fractions that are just numbers, and I'll go through an example in a second, but we just multiply both the top and the bottom of the fraction with the factors to get the bottom to be the least common denominator. And again, I'll go through this in a second. This is something that you'll be familiar with. After we have everything as the lowest common denominator, we'll just add or subtract the numerators as the expression shows, and then simplify. So let's look at this first one, which is going to be 3/4 plus 1/6. We can take the same approach to this as we've done with all of the fractions that we've seen thus far. So again, with 4, 4 is going to be 2 times 2. 6 will be 2 times 3. So we can find our least common denominator by taking our list to be 2 times 2, and then we'll add in any factors in the second denominator that we don't see yet. We see the 2, we don't see a 3. So our least common denominator is going to be 2 times 2 times 3, which is 12. So I'm going to rewrite this as 2 times 2, and I'll leave a little bit of space, and then we'll add 1/6, which is 2 times 3. And what you'll notice is that this least common denominator has a factor of 2, 2, and 3. This fraction here doesn't have that denominator yet, so what we'll do is we'll multiply it by 3 over 3. Now, if we multiply this denominator, I'll get 2 times 2 times 3, which is the least common denominator. This one over here, it's missing a factor of 2. So again, now I have 2 times 3 times 2, which is the same thing as 2 times 2 times 3. So again, this is something that you're familiar with. When I multiply these out, 3 times 3 is 9, 2 times 2 times 3 is 12, plus 1 times 2 is 2, 2 times 3 times 2 is 12, and oh hey look, they have the same denominator, so I can just add them. So we'll do the same thing down here. Now, these two denominators, luckily, we already found their least common denominator. The least common denominator was right here. We already looked at these two fractions. So the least common denominator is going to be x plus 3, x minus 3, x minus 3. So let's write that down here so we don't forget. We have, so the least common denominator is going to be x plus 3 times x minus 3 times x minus 3. So the first thing I want to do is I want to write these expressions with the denominators factored, so it'll just be easier to see. So x squared plus 9 is the same thing as x squared plus 3 times x squared minus 3. And then the next one will be 3 over this guy was x minus 3 times x minus 3. So our least common denominator has 3 factors. We've got 2 of them here. We need the third one. So it's going to be x minus 3 over x minus 3. The second one also has 2 factors, and it's got both of the x minus 3's, but not the x plus 3. Okay, now that everything, and I changed the addition to a subtraction, so I don't want to forget that. I'm subtracting the 2 fractions. So now I want to subtract these 2 fractions. So the denominator is the same for both of them, x plus 3 times x minus 3 times x minus 3. So far so good. Now I get to subtract the top. 7 times x minus 3 minus 3 times x plus 3. Again, I'm subtracting the entire top of this fraction. I'm subtracting the whole thing. So let's carry on the next page. To reduce this top, I'm going to have to expand and then combine some like terms. So distribute 7 times x, and then 7 times negative 3. I'm going to take negative 3 times x, and then negative 3 times plus 3. Again, the denominator stays the same. I continue to simplify. I have like terms in 7x and minus 3x, so this gives 4x. I have like terms in the 2 constants, so minus 21 and minus 9 is minus 30. And then the bottom of the fraction. Maybe I'll write x minus 3 squared, so I don't have to write both of those down. And now I do want to simplify a little bit more. In the top of the fraction, I can pull a 2 out, because both of those are even. Here, I'm done. I can't cancel anything more from the top and the bottom. The bottom is completely, the top is completely factored and the bottom is completely factored. And so the entire process is exactly the same as adding fractions, as in simple numbers, because we're just looking for the common denominator by factoring, and then once we have the common denominator, we can just add. Once we have the common denominator, we can simply add the fractions. You just need to simplify at the end.